What's up, YouTube? I wanted to make a video on relays. This is Automotive Relay, and this particular one has 5 leads on it, and it did have a plastic housing around it, but I just took some needle nose pliers and broke it off, just so I could get inside here and see better and hook these connectors up and stuff. And let me show you. As you can see, 1, 2, 3, 3 on this side, 2 on this side. And it's kind of hard to see, but these are all flat. These two are smaller ones, the blue ones. My blue connectors here are smaller blade connectors, and the red ones are wider ones. And I'm just using standard stereotype blade connectors. And so if you're into car stereos, you know, sometimes they have little small blade connectors in the wider ones, so that's all they used on these. And then I just used a crimp these on. And what I want to show you, first I'm going to show you kind of a drawing I made of the connectors there. See if I can get my stand situated. So here's the pretty much physically how it's laid out. The 3 on this side go 1, 2, 3, and then the 2 that point down go 4 and 5. And it's in a circular pattern on this particular relay. And then I looked up the specs online, and hopefully this is showing up on camera. Let me zoom in a little bit more. Again, over here it's 1, 2, 3, 4, and 5. And then here's kind of a, what I did is just kind of redrew it. And some relays will actually have little diagrams like this on top of it. Mine didn't, so I had to look it up online. And what it's saying is there's pins 1 and 2 are a coil. Pin 3 is a common, and then it normally rests on pin 5, and if you energize the coil it should switch over to pin 4, and that's how that one works out. And if you're interested in this particular relay that I just happened to get, it's I believe this is the number, I can't remember, but it looks like 913157, but I think the part number is this is a manufacturer code, and I think it's an R647P. Anyways, that's auto parts type stuff. And then this is more of an accurate representation of what's going on, where you have 1 and 2 is a coil, and when you energize it, it pulls the common lead from down from the 5 to the 4 position. So that's kind of how it's supposed to operate. And so just to kind of demo that, that's why I hooked these contacts on here. So I don't know if you can see, they actually use pin numbers on the leads there. And I'm gonna pause the camera while I get in there and look, because I can't see where number 1 starts. I think it starts here and wraps around this way, but I need to double check that. I'll be right back. Okay, I wish I had a little bit neater desk to work on, but that's kind of my fault. So this is pin 1, this far right one on the 3 line, and this is pin 2. So if I energize these pins, the common should switch from 5 to 4. And again, it goes 1, 2, 3, 4, 5. So what I got as a demo is, we know the 3 is the common, and let me zoom back out. So I have a jumper lead hooked up to my number 3, and it's just going to one of my meter test leads, and my meter's over there. Let's get the camera there. And so what I'm going to do, again, the 3s, I just happen to, doesn't really matter which lead you use, but I've got the negative lead going to 3, and that's this one here. And then 5, which is this far red one, I've got going to my meter red lead. And on my meter I have a continuity checker, so if it's already on, and if I short those leads together, it should buzz. And in this case, what we're going to do is connect leads 3 and 5 to see if they are indeed closed right now. And because you hear a buzzing, that means lead 3 and 5 is closed. Now I'm also going to hook up lead 3 and 4, and 4 is this yellow one I got here. It's right there next to 5. and I'm going to hook it to the continuity checker, and I don't get anything, as I shouldn't, because according to our little diagram, which is right behind the deal there, right there it's saying that 3 and 5 should be closed and 3 and 4 should be open. So now I'm going to energize this coil, which is 1 and 2, and we'll see what happens. First thing, I'm going to leave this, and the way I'm going to do this is I just got a 12 volt connector here, just plugged in a 12 volt DC, and I'm going to connect pins 1 and 2, and the center of this particular one is positive. Let's zoom out in case I can't see anything I'm doing. So I'm going to, and it doesn't matter which one you use, positive or negative, I just doing it this way. So I got my positive lead there. I'm going to actually hook up, it's going to be noisy, I'm going to hook up the pin 3 and 5, and then when I energize it by touching pins 1 and 2 to my 12 volt power supply, watch what happens. You heard it click and it opened. So that's what it's supposed to do. And so we know that normally it's pins 3 and 5 are closed, and when I activated the coil by charging pins 1 and 2, that the armature opened up. So I know the armature's working, but now I'm just going to verify that when it is charged up between 1 and 2, that pin 3 ends up going to pin 4. So I already got pin 3 hooked up. Again, that's my green lead here. And so all I'm going to do is change from pin 5 to pin 4. And pin 4 is my yellow, so I'm going to just take this here. And in this case, I'm already hooked up. I'm going to turn on my meter. So the meter's on and it's not getting any continuity. Now if I energize pins 1 and 2, watch what happens. That shows me that this relay is working correctly. And you can hear it click, and of course you hear the buzzer when the other side charges up. Let me zoom this out all the way, and I'm going to unplug my power supply. And so, I don't know, I find these kind of interesting, and you can do a lot with the relay. And this relay is unique in that it's already normally closed on one pin. You probably can't see what I'm pointing at there. Again, it's normally closed on one pin, and then when you activate the coil, it opens that pin and closes this other pin. So that's a pretty handy relay, and it's spring loaded, so when you undo the coil, it slaps back to the 5. And there's pretty cool applications you could do. I think this was a, I can't remember what this was, like a brake backup light or something, or a brake light relay or something off that, something like that. I'm not sure. I can't remember which relay it was. 12 volts is kind of high in the electronics world, but in the automotive world, of course, it's very common because you got a 12 volt battery. So I'm gonna get a different kind of, do a little bit more research, get a different kind of relay, and maybe show you guys how you can use this logic relays to make logic switches. And the theory on this, well, this one you're seeing it's acting like a switch, but typically you use a small current, here I'll show you again, a smaller voltage and current in your coil to control the switching of a larger voltage and current over on this end. That's typically the reason why you're using a relay. Although you can use it for just a switch, and this very well could just be simply a switch. And now I actually remember what this was. I think this was off of for a fuel pump, and so they were using that relay as a fuel pump, probably like a start, maybe to help when it starts or something. Anyhow, so I hope you found this video interesting, and I kind of enjoyed playing around with this relay, and I'm going to try to get some different relays and see if we can make some logic circuits out of it, maybe, if I get some time there. So if you like this video, hit like. Sorry it's kind of rambling, and it probably wasn't that interesting, but I don't know, maybe somebody out there will get use out of this. And if you subscribe, you'll see more videos as they come out. And thank you for watching.